Afternoon, everyone. My name's Tom Gonzalez. I'm a vegetable crop specialist with Manitoba Agriculture, and I'd like to welcome you to the fourth of the 5 webinars that make up this year's 2021 Horticulture School March webinar series. Today's topic will be passive solar greenhouses. Over the past number of years, we've presented extension information through the annual horticulture school and via winter meetings. With COVID having changed everything for most all Manitobans, within the way of restrictions, it's changed how we and our partners at ACC and AAFC are able to provide extension information. And we opted to try this webinar format last year, and it was fairly well received. Well, more than fairly well, it was quite well received. And so we continued with that, and we're always looking for feedback. So if any of you have any comments, good or bad, feel free to pass them on. Like I said, this is the second to last webinar. The last one will be next Wednesday, March 31st. And it will be pumpkin and squash production is the topic of that one. As well, we're looking to, in the future, once this March webinar series is over, to do some more webinars, not right away, like not in April or anything, but certainly coming up in 2021. So stay tuned for that. For today's webinar, we certainly encourage questions. And during the webinar, if you have any questions, please enter them into the question and answer feature on your screen. And basically, we will see the questions and be able to deal with them at the end, or even as they come up, depending on how many questions are coming in. Our speaker today is Dr. Poonam Singh from Assiniboine Community College in Brandon. And before we get started, with the content of today's webinars, there are a few questions that we'd like to pose to the attendees related to passive solar greenhouses. So Lori, could you launch that poll, please?
I sure can.
Thank you.
All right, so our first poll is, have you ever grown plants in any kind of hydroponic system? So you can select one, please. There's no. Yes, small scale home owners level. Yes, medium-sized small greenhouse. Yes, large commercial setup. So if you can select one and submit that, that would be great. And it looks like we have pretty much all of our voting in, so I will launch the results. All right, so our results are 73% no, 27% yes, small scale home owners level, and the last two are 0%. Okay, so we'll go with the next poll. And here we go. In hydroponic systems, plants can be grown in, please select one, air, water, soilless potting mixture, or all of the above. If you could just select one, that would be great. Everyone's voting fast, that's great. If you do have a challenge voting and you're not able to, you can just put your answer in the questions tab and we will get that as well. Okay, so we are 100% in. I'll launch those results. Okay, 0% air, 38% answered water, 0% soilless potting mixture, and 62% answered all of the above. Okay, so our next poll, we have 4 in total. Which of the following statement is not accurate about a good growing medium? Please select one. Provides support to plants. stores and releases nutrients, fixes nitrogen, or makes water available to roots. So this is a statement that is not accurate about growing mediums. I'll give everyone a minute here. This one we might have to think a little bit on. All right. Which of the following statement is not accurate about growing good growing mediums? Okay, I will launch the results. 25% said provides support to plants. 8% stores and releases nutrients. 67% fixes nitrogen. And 0% makes water available to roots. All right, everyone, we have one more. And it is an important advantage of soilless medium over soil medium is, please select one, allows best mix of substrates, rich in micronutrients, adds organic matter, or has sand, I think that's supposed to be silt, sorry about that, and clay. That would be a typo I missed. So you can select one, please. Give a couple more seconds here. It's a little more reading on this one. And okay, here are the results. 67% allows best mix of substrates, 17% rich in micronutrients, 8% adds organic matter, and 8% has sand, silt, and clay. Okay, those are all the polls. Thank you very much, everyone.
Well, thank you, Lori, for running those polls, and thanks everyone for participating. That gives us a little bit of guidance for what you're going to hear today. So as I said before, our speaker today is Dr. Poonam Singh from ACC in Brandon. And Poonam, it's all yours. Take it away.
Yeah, thank you very much. Hello, everyone. And thank you, Tom, for introducing me and introducing a bit of the topic. So our today's topic is hydroponic cultivation of vegetable crops. And I work as a faculty for horticulture production and sustainable food systems at Assiniboine Community College, Brandon. I'll start with saying that Community College, Assiniboine Community College is located on the traditional territories of the Cree, Ojibwe, Dakota, Dene, Anishinaabeg, Ojibwe, and Métis people. So the overview of the presentation, what we're going to cover today is what is hydroponics, and what are some advantages and what are some of the limitations of hydroponics, what are different kinds of media choices for hydroponics, what are different common types of hydroponic systems, and what are the important points to consider when we are setting up hydroponics. So in the poll, I saw that some of you answered that hydroponics is growing in water, and the others said that all of above, So the right answer is actually all of above, So it is simply put together. It is a technique of growing plants without soil. So you can grow plants either in air, which is kept humid, or in water, which is kept well aerated, or in a non-soil medium or soilless medium, which is kept moist. So all three, these are part of hydroponics, not just water culture. So you can grow in either of these medium, which is not a soil medium. Anything which is soil-less is hydroponics. So you need to understand when we talk about hydroponics, like how do plants actually grow in hydroponics, to make it successful. So when we're growing in hydroponics, primarily the plants parts which are going to get affected are plant roots, because that's where we are changing the medium from soil to soilless or water or air. So what do roots do? Roots, their function is to absorb nutrients. Their function is to absorb water, and then they also respire. So they exchange gases as well. and then they transmit these chemicals to feed other parts of the plant. But roots also hold the plant in position and stop it from falling over or blowing away. So when we grow plants in hydroponics, we must ensure that the water, air, and nutrients are still supplied and the plant is supported as it would occur if it was growing in the soil. So one of the intrinsic advantage of hydroponic over soil growing is that you can choose any set of different components, any kind of media, and you can use simple soluble compounds, and you can determine the exact amount of each essential nutrient available to the plant at any given point of time. So there are lots of advantages of growing in hydroponics. First thing is that you can grow anywhere. You know, crops can be grown where there's no suitable soil, or whether soil is contaminated. Then maximum yield is possible. That makes system economically feasible in high density and expensive land areas. Generally, one greenhouse, grown hydroponically can produce 10 to 15 times more than the same crop in the field production. Heavy work is reduced as well, so work for tilling, cultivating, watering, and other traditional practices is largely eliminated. Hydroponic cultures are very, very intensive. So a lot can be grown in a small space over a short period of time. You can also grow in multiple levels, especially when transportation cost is significant. These hydroponic systems can be viable irrespective of land values. Um, uh, Conservation of water and nutrients is one of the key features of all kind of hydroponic systems, and this can lead to reduction in pollution of land or streams where valuable chemicals need not to be lost. Pest and disease problems can be highly reduced because you are starting everything with sanitized, clean media, clean seed, and you generally hydroponic systems work in closed systems, mean you recycle everything. So if you start clean, there is a possibility, large possibility of elimination of disease and pest problems. Weed problems are almost eradicated 100%. Environment is very, very easy to control. Like a complete control of environment it's a feature of all systems. When I say environment, I mean root environment, timely nutrient feeding or irrigation, because most of the hydroponic systems are done in greenhouses. So there's that light, temperature, humidity, composition of air. Those all things can also be manipulated. Root zone chemistry is so easy to control. Salt toxicities, if you have, they can be leached out. pH can be adjusted. Also the salts, because they do not bind chemically to majority of the media used in hydroponics, so the problems of salt built up that may occur in soil, particularly when highly soluble nutrients are used, is very, very uncommon in hydroponics. There is less transplanting shock, so newer plants are easy to establish. Crop rotations are not necessary. And it's ease of use is like, if you're used to it, any amateur horticulturist, you can adapt a hydroponic system to home or patio type of gardens, or even in high-rise buildings. They can be really clean, lightweight, and mechanized, once you know how to operate these. However, there are certain, I should have put rather, limitations than disadvantages. So the first bigger limitation of this is that the initial cost is high, and the operating cost is high as well. They produce a lot. If done commercially and wisely and effectively, they can produce, but it's very expensive as compared to field production. And it is a very, very knowledge intensive and a management intensive system. So that skill and knowledge is required to operate the system, like how do plants grow, and principles of nutrition. That's very, very important, for you to know how how to run any hydroponic system. Now, disease and pests, they you can control them quite a bit in hydroponic systems, but if they come, then they spread very, very quickly, because again, it's a closed system. You are recycling everything. So that's also one of the disadvantages, that if they're there, they're going to spread very, very quickly. Then beneficial soil life is absent, because you are actually growing in a non-soil medium, not in the soil, so that microbes, that they are generally not present there. Plants react very, very fast to both um, good and bad condition. Like, I have seen that their reaction is unbelievably fast. You do something wrong in the morning, by evening the plants are going to show, that if there was some deficiency or toxicity. Like, it's very, very fast. But the positive thing is that if there is something wrong and you want to fix it, you can fix it pretty fast as well. If you have if there was a deficiency and you have applied that nutrient, you will see its effect very, very fast. So the plant varieties, they are very specific for hydroponic systems. They are comparatively expensive. They are bred to produce a lot. And there's still a lot of research, I think, that needs to. There are a lot of varieties available, but there's still, that needs to be done to have more varieties available. So when we say hydroponic system, as I discussed in my previous slide, that you can grow either in water, air, and or non-soil, soil-less medium. So there are different types of hydroponic system based on what kind of medium are you using. If you're using water as a medium, so the basic kind of hydroponic system that you will use is standing aerated nutrient solution, or deep pool raft technology, or nutrient film technique, and I will explain these in coming slides, how do they look like. For air, the system is called as Aeroponics. And for soilless medium, you are primarily actually growing in the pots with some sort of medium which is not non-soil. So, and it's just a more method of irrigation, how you provide water. So first system is called as ebb and flow, is also called as flood and drain, and or it's a drip and pass system. So we'll kind of look into these systems in coming slides in detail. So soil, water and air are simple. You're using either water and or air. But when you're using soil-less hydroponic systems, you have a lot of choices for the media, kind of media that you can choose, and that's actually very, very important. What kind of media do you choose? So when you are choosing media, you always have to keep in mind, what do roots require. Roots require water, so you need to have a media which have a good water holding capacity. Roots do require nutrients, so you need to have a media where you can adjust pH, or it can hold on nutrients, and can supply nutrients to the plants the way they're needed. They need air, so you should have a media where it has good porosity and it can have a good drainage ability. Then it should be able to provide support to the plants as well. Also, media should be easily available, and it should also come as a uniform batch with every mixing. So you should be sure that every batch you're mixing is kind of will have same consistency for that media. So based on that, there are some media which are organic and some are inorganic. So organic is anything which is plant-based, that's organic medium, and inorganic is non-plant based. So some media are more popular than others. Inorganic media, peat is very, very common media that is used. Coconut, although not alone, it is kind of mixed with the other inorganic medium, because peat has tendency to hold on too much of water and not let it drain properly. So and it doesn't have a good drainage, so you need to add something to make it kind of drain. So most of the media could not just be one type of ingredient, it could be combination of ingredient, whatever provides the they required, necessities to the plants in the best, in the ideal way. Coconut fibers, once considered the waste product, this is one of the most popular medium these days for vegetable production, hydroponic vegetable production. It comes in small, all size of particles, in chunks, in slabs, in kind of smaller particles as well. Cocoa slabs are very, very popular, and they are used for hydroponic growing of tomatoes, cucumbers, eggplants, those crops. Composted bark and sawdust. Now, bark-based medias or sawdust, anything which is tree-based, they are very popular with the nursery growers, the people who are into perennial trees or perennial fruit trees, growing. But because they have very high carbon and nitrogen ratio, you need to add on some sort of nitrogen, supplemental nitrogen, to make it work. Growers, if you don't have cocoa fiber slabs available, I have met with a lot of growers that they use sawdust in the bags as a replacement for cocoa fiber as well, and that kind of in hydroponics has worked well too. Rice hulls, people use parboiled or burnt rice hulls. They are not a very popular medium because of the possibility or susceptibility of like diseases and pests, associated with those that product. Sphagnum moss is used mostly in floricultural plants. Uh, some kind of floriculture plant. Vermicompost is mostly used in amendment into other media. So these are kind of the more organic mediums. And there's always ongoing research going on these medias like biochar, and there's so many, So you can primarily use anything as a media if it kind of provides all those 3 or 4 things that I have told you, air, water, nutrients, and support. So inorganic medium, these are more popular ones. Rock wool. Rock wool, it kind of looks like more as a synthetic material. It is actually not. It is a granite material, rocks which are superheated to a point that they become liquid, and then they're spun into fibers. So rock wool medium is very, very popular medium for hydroponic vegetable growing. For tomatoes, cucumbers, the common hydroponic medium is that you will start plugs in rock wool plugs, and then transplant them into rock wool cubes, and then those cubes are put over cocoa slabs. That's like standard. I have most commonly, that's what I've seen with the vegetable hydroponic growers. Rock wool has a little bit tendency to oversaturate, so it keeps too much water. So that's why the slabs of rock wool are not used. Only the cubes, and the slabs are mostly for cocoa fiber or sawdust. Something which can drain better. Expanded clay particles, they are also used. They are small rock-like material, and they are used in hydroponic systems, like when you're growing lettuce and other herb greens. The good thing about these are that they can be sterilized, washed, and reused. Perlite and vermiculite, these are also product of a kind of rock which gets superheated, and it puffs to make a popcorn kind of structures in perlite, and vermiculite is a little more like shiny material. Now, perlite and vermiculite, they are not a good media choices on their own because they're very lightweight, very porous. So the most common media, when you go and buy your potting soil, you see peat, perlite, and vermiculite combination. That's kind of the most common media, very much used by potted plants, or floricultural nurseries, or any kind of potted plants. Humus is also kind of a rocky material that's used in summers. The other materials like gravel, metal chips, polyethylene, urethane, grow slabs, mostly at a smaller scale, not used that much commercially. So now let's look into some of these common hydroponic systems. The first, this is standing aerated nutrient system, very simple. this is probably what most homeowners will try at home. This is kind of the oldest hydroponic technique since mid 1800s. So the requirement for this technique are very simple: a rooting vessel, a nutrient solution, air tube, and a pump to bubble the air continuously into the nutrient solution. So this bubbling air serves to add oxygen and also helps to stir the media. But the problem with this one is that you need periodic replacement of the media, generally 15, 20 days, depending upon what kind of volume of nutrient solution you are using, what crop you're growing, and what stage of crop is that. So this has a very limited commercial application, and water and chemical use are very high just because of frequent replacement. Also, the composition of nutrient solution, it continuously changes, and that requires monitoring, and adjusting pH and nutrients in balance. I think that's true for any kind of a hydroponic system, that that the composition is always changing, and so that monitoring of pH and nutrients, like, that's kind of a must thing, when you have a system like this. So a lot of these kind of kits are available online. I was looking, so $150, $160, just the one kind of showing on the right hand side. There are lots, that, but it's very system. You can develop it on your own. This is a picture from our greenhouse. You see on the left hand side, the first picture, these are just the pots that were available, and they didn't have any, there was an option to plug the drain holes, and they were filled with the nutrient solution. And on the top, I'm using styrofoam. And the for net cups, on the right hand side, the bottom picture, that red cup, these are just the party cups, from dollar store. And so that's what I kind of cut and I used it. And you see there's a plug. I started my plugs, rock wool plugs, seedlings into rock wool plugs, and once they were ready to be transplanted, they were transplanted into styrofoam, into the nutrient solution. Now in the first picture, you see there's kind of these were not like straight, they had a little bit of openings. They were more like at an like round oval. So I couldn't cut the styrofoam exactly to that size. So I kind of bought some inexpensive plastic curtains from dollar store, and I covered it to, so that I don't run into any kind of algae problems. And this is the center. I took this picture yesterday, and this crop is like 20 days old, and it's doing pretty well. You see the roots. This picture is also from yesterday. You see the roots are kind of growing well as well. So it's with anything you have, you can use it. If you use a bigger volume of water, it will be easy to keep the oxygen levels, stable. Now this water has to be oxygenated. Now initially, when you're starting up, you should know what the quality of water for any kind of hydroponic system is very important, because primarily that's where, in these systems, if you're using water as a medium, that's what you're growing. But when we say quality, salinity, and pH, that's one thing. Oxygen levels, you need to see that too, because I tested a couple of different water sources in our greenhouse and around my house, and the oxygen levels kind of varied from 3 ppm to 8. 7 or 8 was the highest. 7 or 8 is very good. You can easily grow, but any kind of oxygen, so you can maybe even starting with 4 is not bad, but as plants are going to grow, they're going to utilize the oxygen, and then at one point, the oxygen is going to get very low, and that's going to create totally anaerobic conditions for plant and the roots, and that's going to harm the plant a lot. So this is the same kind of technology, you can say, but little bit more advanced. This is called as deep pool raft growing system, and this was developed in University of Arizona in late 70s, and that's been adopted to commercial production in Canada since like 1990s. So one of the key features of this one is that you have a large pool of water, and you use styrofoam trays with the plants, and then these trays kind of float on these in this pool, and this pool is filled with the nutrient water that is kept well oxygenated. So this kind of allows, because the volume is so big, it allows a large buffer for fertilization and oxygen control. And also the most of these systems are mechanized. So also the transportation is like you just have to pull the trays. That's kind of very easy by flotation too. Although large volumes of water are required at the beginning for filling up or growing beds, and but you can use the water crop after crop, year after year, without having to discard any water, just because sheer large volume of water. In Ontario, there are farms that do a deep pool raft technology for lettuce and other herbs. So you cannot grow tomatoes or cucumbers, the tall crops with big root systems, but but herbs, medicinal plants, spinach, or lettuce, those can easily kind of grow. I visited one of the farms in Netherlands, and they were taking 18 lettuce crops per year in this system. So that's also, you can take a lot more crops, and because it is expensive, you have everything in greenhouse, so you want to take the most out of it. That's what most growers would do. Nutrient film technique. This is kind of a medium scale. It could be from medium to large scale, but that's the system's called nutrient film technique. So in this system, if you look at the diagram, the plant roots, they are suspended in a trough through which nutrient solution passes. And this trough, containing this plant roots is set on a slope, generally around 1%, so that the nutrient solution that's introduced at the top end of the trough, that can flow by gravity at a recommended flow rate, and so that you can collect and recover and filter and sterilize, and on the other end, and reuse, adjust nutrients and pH, and reuse the same nutrient solution. You always generally keep a capillary material like at the bottom of that trough, just to for preventing young plants to drying off. So these kind of systems are also popular for crops like lettuce and herbs. You cannot grow like larger size crops, but in this system, design of crop like width, height, and form are very, very important. What happens is that when root mass increases in size and the volume rate down the trough, that decreases, and as nutrient solution flows through this trough, plants at the upper end, they reduce the oxygen and elemental content of the nutrient solution, and that can actually greatly affect growth and development of plant at the lower end. Besides, when the root mat thickens or becomes denser, that the flowing nutrients tends to move over the top and down the outer edge of the root mat, and that also reduces the contact of nutrient solution within the root mass. So to minimize this, again, growers tend to experiment with the different lengths, of troughs. I've seen that 30 feet long trough, like 9 meter, they are pretty common, and width is kind of adjusted as well depending upon what kind of crop you're using. This is comparatively inexpensive than other hydroponic systems, like the other commercial hydroponic systems, because you can use just the construction materials for making this. Now, one of the big problems with this system is because plant roots are suspended in air, they can dry out very, very fast if any problem occurs, like if there's no solution that's pumped in the tray. And it's very, very, very vulnerable to power outages or pump failures as well. So here is a system which uses air as a medium, called as Aeroponics. These are specialized versions of hydroponics where roots of a plant extend only in air, and they are directly sprayed with the nutrient solution in a form of aerosol mist. You say that in the picture, that spray jet, that's what's used. So the primary difference of this system than other system is the availability of oxygen to the roots, because you are growing in the air. So lots of oxygen is available. And in hydroponics, you have to make sure that you are supplying oxygenated water. And if that's not, there's not enough oxygen, plant growth, development, yield, everything kind of suffers. Also, there's the root diseases, they also develop a lot faster in an environment which is anaerobic. So in those systems, standing water, it depletes the oxygen faster over time. So in aeroponics, because oxygen is surrounding the roots at all the times, and this surplus oxygen that accelerates the nutrient absorption at the root surface. So this is how kind of it looks like in practice. Now, there in this system, there is substantial economies of both water and nutrients. In most of the systems, there is a small reservoir of water that's also allowed to remain at the bottom of fruiting vessel, and so that the plants have continuous supply of water. So a critical aspect of this technique is the design and characteristics of aerosol, like how much is the frequency of root exposure and what's the composition of nutrient solution. Um, these systems yield more. Literature says there are lots of reports that say that the yields of crop obtained in this system are considerably higher than conventional hydroponic system, but the cost of operating, initial and operating costs are generally very high as well for these systems. So now I'm moving on to soil-less medium. As we discussed, water, water systems are called as deep pool rough technology, or standing aerated nutrient solution, or nutrient film technique, NFT. Air, the systems using air as a medium are called as aeroponics. Now these are the systems which are used when you are using soil-less media. That media could be anything. It could be, a mixture of peat perlite, potting mixture, or rock wool, or cocoa peat, cocoa slabs, any medium. So how you kind of, it's more like how you irrigate your crops in that media with the nutrient. Fertigation, not irrigation, I would say fertigation, because in greenhouse, whenever you water the plant, you generally never water it with the plain water. It is always with the fertilizer solution. So that's why it's called as fertilizers and irrigation fertigation. So how do you fertigate your crops? So it's also called as flood and drain. So it's basically how it sounds, by simply flooding the plant root system with the nutrient solution. So this system consists of a waterproof floor or a bench to hold pots, a nutrient solution reservoir, an electric pump, and a piping system for the delivery of nutrient solution from reservoir to the growing beds and its return. And base of the plants are submerged in the nutrient solution for a few minutes to allow the absorption through the drain holes at the bottom of the pot. After which, so that water is allowed to remain in the bottom the uh, in those trays for some time before it gets drained back to the reservoir, where it recirculates back into the system again. So the nutrient solution is used until it is no longer usable, and then it is kind of dumped and replaced with the freshly made solution. Now, these are common type of flood trays that are used in greenhouses. These are they are available from the greenhouse suppliers. They come to a standard size for a bench. Greenhouse benches, and you see there are kind of those grooves on these trays. So water comes on one end. So you will have pots on this bench, and water comes on one end, like front end, and they're sloped a little bit towards the lower end. Very gentle slope, and then it will stay there for some time, depending upon what is the stage of crop and how much water is needed. So it will get absorbed through the roots, through the drain holes at that time. And then after a few minutes, it will get drained out from the other end, the lower end, and then it will recirculated again. Now this is comparatively an easy system, and it gives a good performance, and it needs a very moderate level of care as well. Now this is the flood trays, the same as we shown you in the last slide, that the plants are kept there and they're watered. There's also another version of it where you use capillary mat, which is kind of just a thick mat, more like a carpet. So in this picture, you see the soaker hose on the capillary mat, and you can just use it, just a normal hose, to wet the capillary mat, because it holds water for some time and pots are kept on it, and slowly they keep on taking the nutrients. So that's also is used. And when you are, especially when you are into growing into soilless medium, or you have large number of plants, it's very difficult to water each and every plant. And also overhead watering is not a great way to water plants. The tendency should be that you should have minimum contact of water with the leaves. So the bottom irrigation is better, definitely, in greenhouses. So that's what different. So this is a picture of a flood floor. This is from a greenhouse in DC, which specializes in vegetable propagation. So you see on the top picture, this is a flood floor, and I was surprised when it was so clean. It was like even cleaner than my home. It was very, very clean. And then you see these are holes in the middle of the floor. So there was a tank outside of the greenhouse, which was embedded in the ground, holding the nutrient solution. So plants were kept in the lower picture. You see these are the trays with tomato seedlings, styrofoam trays with tomato seedlings. So they are kept on it, and the water comes out of these holes and floods the floor for a certain period of time, depending upon crop stage and type of crop. And then after that, it kind of drains back into these holes and goes to that reservoir. So that's see, when you have something propagation nursery, it is very difficult to propagate it, if you don't have a system like this to individually propagate. Your only other economical way is to do it overhead, which is not again great. So this is a commercially very, very much commercially used method as flood floors. Now there's one problem with this system, is that because the sump and the enclosed nutrient system, they are in the ground, their temperature would be ideal to the surrounding soil, meaning that the nutrient solution would be colder like than the ambient temperature, which is the undesirable trait, and that can harm plants when a nutrient solution is dispersed into the growing medium. However, growers, because the large scale growers, they have different kind of insulating material and other things built around those pumps to keep the temperatures stable. So this is the same, the flood floor again. These are grafted tomato seedlings, the same greenhouse. And you see flood floors, and they are now in the rock wool cubes. And again, this is very, very feasible system for nursery like this. So then is the drip irrigation system. Like you're all aware, this is unlike any other drip irrigation system. Very, very popular with the hydroponic growing of the bigger crops like tomatoes, cucumbers, eggplants, peppers. Yeah. So very, very widely used in commercial production. So you can grow plants either in bag, pot, bucket of soilless media, or they can be grown in coco peat. or in a rock wool slab, and the nutrient solution is held in a reservoir. So a pump comes periodically and pushes the nutrient solution through a network of spaghetti tubing that you see, these drip lines, and that delivers water at the base of each plant, and then the excess water kind of drains down from the bottom of pot, and that's collected and returned to the reservoir where it is reused for next watering. Um, commercially commercially used method. On the picture on left hand side, you see the drip irrigation method, which is, these are tomato crops. The media, the bottom slab is a cocoa slab, and there is a rock wool cube that's placed over these rock wool, and there are these drippers, that's bringing nutrient solution to this. Another greenhouse, this is, here the growers using not there's rock wool cube. You can see this is pepper crop, but instead of having rock wool, that the bottom bags, these were in-house made bags. They were made, and they contain sawdust. I think it was cedar sawdust. This was kind of the smaller system that we developed here at Assiniboine Community College. And you see there was an experiment, and you see this like really at a smaller scale, and this can be replicated through as many benches as possible. You see there's kind of a reservoir at the bottom of the bench. There are two reservoirs. They are two because I was doing an experiment on keeping the oxygen levels stable at a certain point. However, only one is enough because you can use the same one as a feed tank and as a drain tank as well. The media we used is cocoa slabs and rock wool cubes put on it, and there are this drip system that was used. Here's the crop, when it was growing, the same system, and it performed very well, even at a smaller scale. The cucumbers which were grown. These were some of the cucumbers that we harvest. Now the picture on the right hand side, you can't read it though. There are three, I did a root assay where I tried the different levels of oxygen to the cucumber roots to see, how do they affect the plant, the cutting, that the cucumber plant on the left hand side, that was kept in 4 ppm of oxygen, the middle one in the 8 ppm of oxygen, and the side one was kept at 15 ppm oxygen. The what I found was that you can see that the root growth and root length, everything is significantly more when more oxygen was given, and it is comparatively less number of roots in 4 ppm, even lesser than the 8 ppm one. What I found from the yield point of view, that there was not much difference with 8 and 15, like they had kind of the similar, little bit higher yield, you can say, were very insignificant though. You can say like the similar yield with 8 and 15 ppm, but yield was higher than when the water was given at 4 ppm. Another thing I noticed that if that oxygen was not, I was replenishing oxygen to keep it at 4, 8, and 15 every day. But when it was not replenished, it was going so low, so fast, like it will move from 4 ppm to 1 ppm like in a couple of hours. That kind of condition is now very, very detrimental for the plant. Also, the plants were, they were tall, big, they have a lot of leaves, so the requirement was more. So I figured out any kind of additional oxygen is benefit. Another finding I got, which was very interesting, was that the yield still, you can say, even there was effect on yield, but the bigger effect was actually on the post-harvest quality of life, of the shelf life. The shelf life of the cucumbers that was produced with higher levels of oxygen was way more than what was, with the lower levels of oxygen. So it did affect, so they decayed less, they stayed fresh longer, their So they become softer later. The one with the higher oxygen, they had more shelf life, better skin, but they were more firm as well. So these are, like, in the nutshell, all basic common hydroponic systems. They kind of vary from really small to large commercial scale. There are just the basic principles of growing. When hydroponics, we have mostly talked only about the root system, nutrient solution, how that's delivered. Remember, the above ground environment is equally important. What kind of temperature, humidity control, is there in your greenhouse. So that's also important, and that has significant effect on yield, post-harvest growth, development of crops. So there are a few things which are kind of very important if you are starting a hydroponic system. Now, EC pH meter is must. pH is, generally our waters will have pH around 8. And in hydroponic growing, your pH, you require pH somewhere between 5.8 to 6.2, 6.3. Because pH does affect a lot on availability of nutrients. So you want to use something, to bring your pH down. And there are solutions available, which are pH down. We get ours from Home Depot or Canadian Tire. It just says pH down. You add a few drops and it can bring the pH down. EC is electrical conductivity. So there are meters which kind of can measure you EC, pH, salinity all together in 1 meter. So EC is, it kind of tells you how much salts do you have. It does not tell you what particular kind of salt you have, like how much magnesium sulfate do you have versus calcium nitrate, but it will tell you, like, what is the electrical conductivity, what is the total kind of concentration of salts, like how concentrated your solution is. And there are numbers, that you can there's lots of resources, that can tell you that what should be EC at a particular stage of plant. Generally, I started with when it's seedling, I started with 0.5 millisiemens EC, and then for cucumbers, I went to the maximum of 3, 2.5 to 3, and that met the requirement. There are a lot of recipes available on internet as well for different crops that you can mix. But if you're doing it homeowner level, there are a lot of ready mixes available as well. They say this is for lettuce, this is for tomatoes, that can be used too. Don't have experience using those. I make my own mix, but that can be used. Irrigation valves, you need to time your irrigation. We bought this. This is from Hunter Industries USA model ICC2. We bought this from Canadian Tire, and this was to regulate our irrigation. So initially, irrigation was only for you should only give irrigation during the daytime, not in the nighttime. So I set it up at 1 minute every 30 minutes from planting, and then as plants grew, I reduced the timing to 1 minute for every 15 minutes thereafter. So that's some sort of timer, and irrigation was there important. Media is very, very important. If depending upon what kind of crop you are growing, so this cocoa slab and rock wool, these are more for tomatoes, cucumbers, eggplant, like the taller crops. That's how they're most common standardized media. But there are other media choices too. I would say these are the most popular ones. Then something to generate oxygen. Now people use air stones. Air stones are great, but if you look at the oxygen level, they stir water a lot, but they do not add that much of oxygen. I found this called Grow O2. This was from Oxygen Research Group LLC, Minnesota, and this is available online. And what it does is that it has these small units that you put it in water, and it breaks down the water by electrolysis into oxygen and hydrogen ion. So it kind of adds a very, very small particle of oxygen, nanoparticles, and that stays for a very long period of time. So I ran for my system, I only ran it for 3 hours in the morning, and that was enough to keep it for the whole day and night until next day. So or air stones too, so additional oxygen always benefits. I think when you are thinking of especially growing in water cultures, that's kind of a must thing to have. So the important points I would say that check and adjust your EC and pH, and then keep a very close eye on plant health and growth, because things can go very bad very fast. So you will have to monitor it at least every day to see, if you have started seeing some sort of deficiency or something, you have to really figure out within a day or so. Otherwise, it when it starts, it's already, that the problem's already there, and then it's going to go very very fast, very bad, and then the worse it gets, the more difficult it's going to be to remedy it, to correct it. Always use opaque materials so that you can avoid algae growth. It can be a big problem in hydroponic systems. Additional oxygen in root zones always beneficial. And what kind of system do you choose depends upon your space, your use, your purpose, your management practices, whether it's a small homegrown level or you have more advanced, market garden, or you have more commercial setup. You should always select suitable media. And, root is going to be root cause of everything. So you have to select right media, right nutrient solution, and right varieties. Again, you want to choose varieties which can produce a lot in hydroponic systems, and there are varieties available. So just something off the shelf might not work. The varieties are comparatively expensive too, but because they have that genetic built into it, which is very which is which helps to produce a lot. So that's all for my presentation. Thank you very much for listening, and I'll be happy to answer any questions you have.
Well, thank you very much, Poonam. There certainly have been more than a few questions come in. Here's one from Joy. Is it possible to practice hydroponic system to all kinds of plants, especially those with large root and tuber vegetables?
It's not a great system for tuber vegetables. Um, I think anything if you have above ground, I did try it on radishes a little bit. They were okay, but they came out to be a little more distorted as they would be in the soil. I think, just because it also depends. If you're using soil-less media, there's no problem. If you're using peat-based media, it's going to have the similar shape, similar production. But when you think of water culture, I don't think it will be an ideal media for growing root or tuber crops. Yes, larger crops you can grow, like tomatoes, cucumbers, again, you have to choose the right media. As I told you, the cocoa slab, something that can support the plant. You need to have the system which can support the plant very well as well. And there are different kind of training systems that you use for different plants. But those, yes, with the bigger root systems, they can definitely grow. That's not a big problem. Most of it is that the root crops, I think it will be a better choice will be to go for a soil-less medium culture, like anything peat-based or even cocoa peat, mostly in the pots, and they produce well. There's no problem. Like I haven't seen much difference them producing in soil versus in soil-less medium, but not so in water culture.
Well, that's nice. That's good. Thank you for the answers there. There are some more here. Just let me get them up here. Sorry, I'm having. Here we go. Okay. For plants grown in a pool of water hydroponic system, how is harvest usually done?
Sorry, how is what done?
Harvest. So if plants are grown in hydroponic system, how is harvest usually done?
Okay, so for mostly water culture, you grow crops which are leafy greens, lettuces, which do not grow. Aerial parts are not big enough. Like you can So for lettuce, you can just harvest it, a couple of leaves as you use it and let it grow. And they keep on growing, So generally, um, you have short lettuce and other herbs, they don't have a very long growing period. You can have like 2 months or 3 months, and then you will just harvest it the way you will harvest it from soil. So if you have cilantro, you will harvest a couple of leaves and it will keep on growing back. So it actually produces more than it will do in soil, because you are giving it straight nutrient solution. And there's lots of leaves you can get, so you will harvest it the way you will just do it in soil grown
Okay,
crop.
that's good to know. We have another question here. Can you talk about growing strawberries
Mhm.
and what type of media, etc., is what they're asking about?
Yeah, so strawberries can grow very well in hydroponic systems. You can grow it in bags. Generally, how commercial growers do is that they will have troughs, hanging troughs in the greenhouses, because they don't want the strawberries to touch the ground. So which will kind of hang about a meter high from the floor, and on those troughs they will have put the bags of either sawdust, or it just could be a bag of coco peat, or it could be a bag of shredded coconut peat, like not just other peat and coconut peat both. And then you can grow your plants well, with the drip system. So that grows well, with that drip system. Strawberries grow pretty well. I have seen them, being commercially used in BC, and I have seen them, they're growing very well too. Yeah.
Okay. Another question came in, and do you have any recommendations for where to buy cocoa slabs and rock wool cubes, either online or in store in Manitoba?
Yeah. So that was really hard for us to source as well. Now the cocoa slabs, we got it from a company called Canna Cocoa, Canna Cocoa. They're mostly making it for cannabis culture, but we use the same ones. However, I wanted more commercial ones from Grodan. They just don't supply here, and also not at a smaller level. But these performed. I won't say best, but pretty good as well. So there's companies, so online, we got online. I think one was for 50. It was expensive. I think $50 or so.
Mm, okay.
As far as I remember, don't take me. I might have to check that information. As far as I remember, yeah. For Rockwool cubes, I think online, I can, send that information to Tom to check like where we source it from. It's been quite a long time that we had that in our greenhouse, but I can certainly share that with Tom, and then that that where we got that material.
Yeah, and if you can do that, then we can push that answer out to the attendees of today's webinar for sure.
Yeah, yeah.
Okay, and there's another question that came in. It's related to, and the person calls it the slide in your presentation with all the tools. And they're asking, where can you purchase these items? You want to?
Oh, yeah, I will. Sorry. This one? Can you
Well,
see it,
I'm
Tom?
not sure, but let's go with that one for now.
I think this is the way. So ECPH meter, like there are so many companies online, but even spray, that's where we got it from Winnipeg, and they sell it too. But there are Fisher, and like there's a lot of Canadian companies. If you just put ECPH meter, there's all kinds. This one, most of them, they will come up either EC meter or pH meter. This one does come with ECPH and salinity meter. Like there's one more thing, so it can do a couple of things. It was, I think, around $300 something. And this we bought from Even Spray in Winnipeg. This Grow Oxygen, this was around, there are different units. They come for 10-gallon water, 20-gallon water, and more commercial ones. I think the 10-gallon was one was this Grow O2 system was 160 or 170, and this is available online as well. So it's just called, if you Google it, O2 Grow system, they sent it from Minnesota, and it was pretty fast. We ordered it and it just come within a week. So they sell it commercially, and their sale is mostly online. This irrigation wall and other supplies, like irrigation supplies, they were all mostly from Canadian Tire or Even Spray. So media, as I told you, cocoa slabs, they were from Canna Cocoa, company called Canna Cocoa. Canna, I think name of the company is Canna, and they're called as Canna Cocoa. And the rock wool cubes, I can check it for you. Where did we get those? Yeah.
Yeah, and once, excuse me, what we can do is once you have where you got the Rockwell cubes, we can put that, we'll have the registration emails for all the attendees, and we can just push that out. So no worries there.
Yeah, yes.
Let me just check the chat here. Here's one more. Paulette is asking if you can repeat the best pH range. Was it 5.5 to 6.3?
No, it's around 5.8 to 6.3. That's
Okay.
mostly your target, is that where you want to keep. It depends, varies a little bit with the crops, but that is most of the crops, that is what the target is in hydroponics. For your EC, electrical conductivity, for example, I'm growing lettuce at this stage. The picture that I showed you, I'll run back to that here. So we are in the when they were seedlings, the right hand side picture, I used 0.5 EC nutrient solution. Then on the left hand side, these are at 1, and the central, they are at 1.5, and at the maximum I will go to 2 millisiemens ms, like that's their units, millisiemen per centimeter. So 2, and for cucumbers, like so the crops like this in greenhouses, the growers go up to 3.5, around 3 to 3.5 when the crop is fully grown. Like this one, at this stage, our EC was around at around 1.1, between 1.2, and then here they were like around 2.5. And yeah, I think that's what I meant at the maximum. However, this is kind of the middle stage of the crop. We grew crop, and then they trained it, and it came down. This is in passive solar greenhouse, and so I kind of I think the maximum for me was 2.8 and 3, and depends upon, look at the cucumbers versus lettuce. It has so many leaves, it does, and it it produces fruit. Anything which produces fruit, you will have more nutrient requirement than when you're just harvesting the leaves. So
Right.
it's and specific kind of like calcium is needed at a particular stage. So those yeah, so that's kind of, so EC and pH, like that was the range we kind of maintained. Yeah.
Okay, well, that's good to know. There's another question here, kind of related. How regularly do you need to monitor things like pH, electrical conductivity, salinity, like that, those kind of parameters for the hydroponic systems?
Every day. Every day, first thing in the morning, you do is that you go in the greenhouse, you check the EC and pH of your feed solution, but you also check the EC and pH of what is coming out of your drain solution too. So that is kind of must, because each salt built up can happen. There can be a number of reasons. Let's say you have cloudy days for many days outside, and plants not transpiring, so those nutrients are just gonna sit in the root zone, and they may you are just feeding at the same level of nutrients. So you might have a very high level of electrical EC, high nutrients and at the toxic level. So you need to check that, in the feed solution and of the drain solution every day, first thing in the morning. That's all the greenhouses, when you were hired as an assistant grower, and when we teach our student, that's what we teach. That is what you do each day, every day. And if you have, let's say, salt buildup, then you have strategies that you reduce your nutrient solutions EC, or you run plain water for a day to clean the system up, otherwise. So that's, it's not like soil, because soil is a lot of buffer. You apply something today, if there's a problem today and you have applied a fertilizer today, if there is a deficiency, that has started building, you will see the symptoms maybe in 10 days or so. And if you have put something for remedification, you will also see its effect in another, like, 10-15 days, because soil has organic, it's a totally different, you have salt, silt, silt, clay, those particles kind of have a cation exchange capacity. So soilless medias, you don't have anything, they're neutral medias. Actually, you want a media which is neutral. You do not want a media which keeps on breaking and keeps on adding things on its own. That's why even when you're using organic material, you use cocoa peat, which is organic, but it doesn't break up. Use bark, sawdust. It doesn't break up to add anything on its own, because the whole purpose of growing in hydroponics is the level of control that you want on, what you are feeding the plants in, and how they're looking, how you're steering them to grow. So you don't want that, so that's why, that kind of control is very essential, and that monitoring is very, very essential on everyday basis.
Okay, well, that's good. Here's another. Do hydroponic crop production systems work well in passive solar greenhouses?
Okay, so they do. The short answer is they do. There are differences. However, we did a trial in passive solar greenhouses and in conventional greenhouses. So I did not find much difference. There was a little bit less yield for cucumbers in passive solar greenhouses as compared to conventional industry standard greenhouses. But it was still good yield. They performed well, but it was cucumber, which is like really a heat-loving crop. So it is more, tropical kind of crop, And however, there was a huge difference in the post-harvest quality. The plants, the cucumbers, the fruits, they were grown on plants in conventional greenhouse. They were good for 21 to 28 days. Like, they were really good, and still, firm, less decay. And the plants which were grown in passive solar greenhouses, they decayed by day 7. They were all like highest level of decay. So, and that is mostly happened because of the erratic changes in temperature. Like, you have a very high temperature on sunny days, and then in the nighttime temperature falls, another day is cloudy. So that kind of fluctuation, I think that had effect on, how the water was transpired into the plants, and how the fruits took it. And so, but yield wise, they were all, for first 1 or 2 days, they were all good, edible, nice, yield was good. I think the post harvest quality wasn't great in a passive solar greenhouse. I am doing experiment of lettuce and kohlrabi in the passive solar greenhouses too. What I am observing is it is a cool season crop, and at this time of the year, passive solar greenhouse has starting becoming little hot. So I'm seeing a little bit of let's say reddish brownish coloration on the plants, which I think is an effect of some sort of heat stress. I'm not sure though. But so yes, they do produce depending upon what time of year you are doing, and also which crop you are doing. But they you can definitely they hydroponic systems do work well in. One thing you have to take also care is that if you're oxygenating, if the temperature in greenhouses go very high, your oxygen levels are going to drop. The hotter the water, lower the oxygen levels will be. So you might have to run your system for a little longer to keep the oxygen levels at a higher level.
Yeah, I can see where I can see what you're saying there. So how often do you need to change the nutrient solution in a hydroponic system?
I would say, depending upon the crop cycle, at least for lettuce, I will at least in a 2 months period, I will change for 3 times. And like 15-20 days, I would say. Yeah.
Okay.
And for cucumbers, depending upon when the plants are small, you can still go with the same nutrient solution for a longer time. But as the plant starts becoming bigger, their nutrient requirements go higher as well. And then for the plants which are fruiting, like tomatoes, cucumbers, etc., when they're fruiting, they're taking a specific kind of nutrient more than the other. So then that sort of imbalance will develop. So I would say, so in 4 months crop, I did that 4 times. I would have done earlier as well, but just to save some nutrients, I did it around like 25 to 30 days for cucumber crop, and that worked well. Yeah, we didn't find much problem with that. Yeah.
Okay, well, that's good. Here's another one. Which vegetable crops can be successfully grown in hydroponic systems?
A lot of crops, I would say. Again, tubers are probably not great for water culture, depending upon what kind of culture you're doing. Aeroponics is very expensive, so I guess there are not many units. They do it because of the initial cost. I will talk more about water. For water culture, leafy greens, lettuces, medicinal herbs, they kind of work very well. Anything in NFT systems also, nutrient film techniques, the same, lettuces, spinach, corianders, other, leafy herbs, leafy greens, they work very well. And you can just stack them not just horizontally, those systems can be stacked vertically as well to make more use of vertical space. There are all kind of designs out there, that can be used, for crops like tomatoes, cucumbers, peppers, eggplant. These 4 crops are commercially grown in Canada in hydroponic greenhouse systems. No, eggplant to very small quantity, but tomatoes, cucumbers, and peppers larger quantities. So for them, the best worked out cultures are drip systems with the cocoa slab and drip system with any kind of media as a slab and cube media kept on it. So those crops were, I think, you can grow many different types of crops. Other crop like squashes and cucumber. It comes to the economies too. Like it is an expensive unit. It's very capital intensive unit. So you want to invest into the crops which are high value and which can for which the technologies are more standardized over others. So these crops are the crops where the technologies are standards. However, there are people growing wasabi, things like really niche crops, wasabi and whatnot into hydroponics too. It's just, I think growing is not a problem. You can grow, you can adapt your hydroponic systems to any crop you want to grow. It comes down to, is it gonna be really cost effective? Is it going to be wise to spend so much money and invest into hydroponic system over growing into soil? Like what kind of high value crops should I, what season is it? If it is a season extension, but do you want to use it during the summertime when there is ample space outside, or if it is a commercial operation, what a year-round operation, what I'm investing into, what I'm getting out of it. I think economics is important, but crop wise, I would say most crops you can make them work in hydroponics.
Okay. Here's a question that's come in on our Q&A here. Not sure I understand it totally, but here we go. Is hydroponic system practices currently designed for small scale production or large scale? And what is cost effectiveness and its profitability? So I'm thinking they're asking, is hydroponic system able to be used on small scale and large scale both? And what is the cost effectiveness and profitability?
Yeah, so they can be used on both, the medium, small scale at the farm level. NFT systems are very popular systems because you do need a greenhouse, that investment is there. You need to run them, at a fuel or any other, and there is other operating cost as well. But the operating cost, like the equipment cost, is comparatively smaller. And you can run it at a smaller level, having smaller reservoirs, like they can adapt to smaller levels too. And most of the farmers, I cannot tell you the exact number, like what is the cost of producing a crop like that per acre. But most of the farms that I have visited, um, uh, you know are using NFT systems, are market gardeners mostly. And they, because you can produce so much, 12 to 18 crops of lettuce, so there is investment, but there is a lot of production as well. That if you have a market established for that, there's definitely viable. That's why they are popping up everywhere. They definitely, that is something not just theoretical. That is something really practical, and it's coming almost every smaller, bigger community, even in the developing countries too. With the larger, there's a big investment, more so on the greenhouse structure and the systems, because everything is automated for those. You have Argus systems fully automating your fertigation systems, your environment control. Again, it is a very management intensive systems. You need to have a thorough knowledge of reading the plant, what that plant is telling you. If there is some problem, how do you fix it? It's not just setting up the system, it's just the day-to-day challenges of, and everything. The greenhouse growers, when they grow, most of their decisions are based on sunlight. So what the sunlight's going to be for next 2 days, how should I maneuver my crop to keep going? You don't want your crop to kind of produce all at once and sit. So your tendency is to kind of make the crop do a marathon instead of sprint. So that slowly it's kind of, you're pushing that plant to regularly producing and producing more. And so that all depends upon what kind of light that's coming in, and you manipulate everything according to that. Your growing environment, your nutrition, what your plant is doing, and you read the plant and make it work. So they are very, very successful in commercial setups. Again, the crops like tomatoes, cucumbers, peppers, those crops are more standardized because you have now varieties available as well from these breeders, which, for example, cucumbers, you cannot compare it to the field cucumbers, because these varieties are like about $1 or $2 per seed, and they are bred to have only female flowers, and without any seeds. So they are bound to produce way more than an outside field variety would do, because then your management and knowledge as well. So they are very viable. They produce almost 10 to 15. You can do, it's a general notion saying that one greenhouse can feed a city, and you can produce a lot. Generally they produce 10 to 15 times more, so they are definitely viable. You really need to research thorough when you're setting up that kind of system, not just on the system, but also, when you started, I would definitely advise to start it from a smaller system and a smaller setup, because so that you can learn, how that crop, even I'm producing lettuces now at this time of year, I'm going to repeat it in summer, again in fall, again in winter, and I will have a totally different performance of a crop on all those three seasons. So those things need to be standardized. Most of my work is now is kind of in that hydroponic system. It's going to be that sort of system. So definitely, we can share whatever information on the research side we generate here, but yes, they are definitely viable both on small, large, any scale.
Okay, well, that's good to know. Just gonna double check. I don't see any additional questions here. I'm just gonna double check the Q&A, make sure my old eyes are still functioning. I don't see, just let me go slow here. I don't see any new questions in there. If anyone has any additional questions, you can type them in while I'm wrapping up here, and I'll check one more time. I'd like to thank everyone who took their time today to log in and listen to the webinar, and I'd like to thank Poonam for taking the time to present today. It was very informative, and I don't see any additional questions. So with that, after thanking everyone there, I'm going to say have yourself a great rest of the day. And if you're interested, come back next Wednesday for the final webinar in the series on pumpkin and squash production. Thank you very much. Have a good afternoon. Bye.
Thank you very much. Thanks for participating, everyone. Thanks for listening. Thank you very much. Thanks for the opportunity, Tom.
Yep. Bye.
Bye-bye. Bye for now.